Good morning, class. We are looking at module 1 of statistics, module 1 for practice test number 1, covering chapters 1, 2, and 3. And here's chapter 2, exploring data with tables and graphs. Given the frequency table, here's the frequency table. Answer the following questions. The number of classes in the table is. First, notice we have the age group. That's one column from 11 to 20. You see the frequency in front of it, 5. That means the number of people in the age group of 11 to 20 is 5. We don't know how old they are. We just know the range, okay? The next group, 21 to 30 is 6, 31 to 40 is 9, 41 to 50 is 11, 51 to 60 is 4. And this is called frequency distribution table, or just the frequency table, or FDT, frequency distribution table. So we want the number of classes. So this is one group, second, third, fourth, fifth. Therefore, we have 5 classes. What is the class width? Well, let's look at the concept of a class width. Class width, if you look at one class, any of them you pick, is the UL upper limit. These are the lower limits. That means the smaller values. These are the upper limits. So the minimum value for the first class is 11. The maximum value is 20. For example, for class number 5, the minimum value, the lower limit is 51. The maximum value or the upper limit is 60. So if you pick any class, this one would be 20 minus 11 plus 1 unit. This one would be 50 minus 41 plus 1 unit. Any of those that you pick, and it becomes 10. Now, the reason I say 1 unit, because a unit may represent 1, may represent 10,000, it may represent 0.1. So this is one way to do it. Or if you look at 2 consecutive groups or classes, then just subtract one from the other. For example, let me pick some and then I'm going to erase them. If you go with these two, 51 minus 41. If you go with these two, as long as they're consecutive, 50 minus 40. So that's how you do it. But when we go with one of those classes like this one, if you go with one of those classes like this one, the upper limit minus lower limit plus 1. But if both limits are upper or both limits are lower, just one, the larger one minus the smaller. The midpoint is defined as the sum of the lower limit and upper limit divided by 2. That's how it's defined. So lower limit plus upper limit. So 41 and 50 in this case, because we want the fourth class. 41 and 50 and divided by 2 gives us 45.5. That's how you find the midpoint, the lower limit plus the upper limit divided by 2. The lower boundary of the fifth class. So now these are limits and we want to change them to the boundaries. The way you find the boundaries, you add the upper limit of one class to the lower limit of the next class and divide it by 2. In other words, the midpoint of these two numbers. Okay. And this would be, the result would be the lower boundary of the fifth as well as the upper boundary of the fourth class. The answer is 50.5. How do we get that? 50 plus 51 divided by 2 is 50.5. Midpoint of the upper limit of the fourth class and the lower limit of the fifth class. That's how you find the boundary. This is the lower boundary of the fifth class as well as the upper boundary of the fourth class. The upper limit of the first class, remember, these are the lower limits, these are the upper limits. So the upper limit of the first class would be number 12. What is the sample size? Look at the frequency. This means there are 5 in this group, 6 in this group. So what is the sample size? Add up the frequencies. Add up the frequencies. 5 plus 6 plus 9 plus 11 plus 4, and the answer is 35. Add up the frequencies. Now, we're going to continue with the same question. I put it here and here. And we want to find the relative frequency. And remember, in the previous page, we found the width to be 10, W is 10, and N, the frequency or the summation is 35. So how do we find the midpoint? How do we find the relative frequency? By definition, the relative frequency is R F equals F over N. So if you want a relative frequency, find the frequency of a specific class and divide by the total size. We want it for the first class. The answer is 5 divided by 35. So by definition, relative frequency is F over N. 5 over 35. Now, 5 over 35 is the answer. If it's a fraction, you always put it in lowest term. If you were to write it as a decimal, like so. If you were to write it as a percentage, like so. So you have to pay attention to the way they want it. This is the exact answer. They may ask you for the percentage, percent relative frequency, or decimal. They're all the same, different formats, fraction, decimal, percentage. So what I want to mention is how we find all of them in general. So if we find this one as 5 over 35, this one is as 6 over 35, 9 over 35, 11 over 35, 4 over 35, and you simplify. That's how you find the RF. Okay, everybody? Now, what I want to add here, so that's RF and you simplify. I'm going to leave it for you to simplify if need be, or percent. What I want to explain is the midpoint. If you recall, we found one of the midpoints to be 45.5 for the fourth class. We found that, right? Now we can do the same thing for the rest of it. 11 plus 20 divided by 2, 21 plus 30 divided by 2. But I want you to pay attention to the method that I'm going to explain. This was found before, right? Do you have to calculate the rest of them? If you know the width, you don't have to. If you add the width, it's the next one. If you subtract the width, is the previous one. Subtract it again and subtract it. So if you calculate, for example, the first one, keep on adding the width. That's how fast it goes. I want to discuss the boundaries. Okay. What did we find? We found the boundary of the lower boundary of the fifth class previously. So we found this one before. Of course, what I'm doing here, I want to find all of them, okay? That's why I put it in the table. So if these two are the same, and I know the width is 10, do I have to calculate the rest of them like that? Just use the 10. See how easy the width, see how easy you can find the answer. So you go and add 10 becomes 60.5. You subtract 10 becomes 40.5. You subtract 10 becomes 30.5. You subtract 10 becomes 20.5, and you subtract. So if you have one of them, for example, if you find this one, right? If you find this one, just keep on adding the width. This is a fine, fast way to find all of them. So that's why I wanted to remind you about the boundaries, which is the midpoint between the upper limit of one class and the lower limit of the next class. Find the model class and the mode. Well, if you recall, mode means the highest frequency of occurrence. So basically, which one has the highest frequency? This one. So this is the class. That is called the model class. And the mode is, they take the midpoint of that. So for a class, the model class is the one with the largest frequency. As we know, it's 11. Therefore, fourth class from 41 to 50. Okay, so this would be the class of interest. The mode, by definition, is the midpoint for a class. The midpoint we know for this class to be 45.5. 45.5. The following frequency table describes the speed of drivers ticketed through a 30 mile per hour speed zone. Calculate the relative frequencies for all classes. Well, we know the relative frequency by definition is F over the RF is F over N. RF, short for relative frequency, is F over N. So for example, in this case, first and foremost, let's find the N. Let's add up 25, 14, 7, 3, and 1. So N is summation of X. This is the summation sign sigma, capital sigma, summation of X. Add them up, we get 50. So what would be the frequency, the relative frequency for this one would be 25 over 50. This one 14 over 50, 7 over 50, 3 over 50, 1 over 50, and we can simplify. So 25 over 50 is 1/2, 14 over 50, 7 over 25. The rest of them are the same. Now, those are relative frequencies. If they want percent relative frequency, or you can change them, but if they don't, you're fine. What percentage represents the speed of 53 miles per hour or less? So you look up the 53 miles per hour is the upper limit of the third class. So 53 miles per hour or less, that means this, as well as this one, all of them are less, right, than 53. So in essence, you can add, since you want the percentage, you can add this one, and this one, or you can add this one, and this one, and divide by 50. Cumulative frequency distribution of 53 miles per hour or less refers to the first three classes. So we can add up 0.5, 0.28, and 0.14 percentage-wise. Or better yet, 25 plus 14 plus 7 divided by 50. Again, an exact answer is about 92%. What about the class boundaries? Well, you remember the meaning of a class boundaries? Boundaries are the midpoint between the upper limit of one class and the lower limit of the next one. For example, these two, the midpoint is 45.5. And if that one is 45.5, that means the upper boundary of the first class, lower boundary of the second class. And then all you have to do, add the width. The width is 4. Okay, so we get 45.5 right here. The width is 4. Why is that? Well, there are a number of ways. 61 minus 57, 51 minus 50, 46 minus 42, 49 minus 45, or 45 minus 42 plus 1. So 2 ways. Let me quickly show you. One would be if you go with the first class, 45 minus 42 plus 1. If you go, for example, with this 2, you can say 61 minus 57 is 4. And so all you have to do, if I add 4, I get 49.5 and I put it here too. And I add another 4, I put 53.5 and I put it here too. I add another 4, 57.5 and I put it here. And I add another one, 61.5. What about the first one? Subtract 4, you get 41.5. So those are all of the boundaries we need. Again, you do have the practice tests, you have the solution to practice test, and here's the PowerPoint explanation with details. We want to continue with the same question, and the next part is asking for us to construct a histogram corresponding to the frequency distribution table. And the way it works, when it comes to histogram, the horizontal axis, you can call it the x-axis, would be the limits, the midpoints, or the boundaries. You can use any of it. The limits, the midpoints, or the boundaries. The reason I'm going to use the boundaries because for the next graph, when we discussed the concept of an ogive, it's coming up, we always use the boundaries. So you put the boundaries here, and here's the boundaries. So 41.5, 45.5, 49.5, so on. So you put all the boundaries, and the first one gives you a bar with the height being either frequency or percent frequency. Which one? You read the question very carefully. This is asking for the actual frequency. That means those numbers. If they use if they ask you for percent frequency, you put that, but ultimately the graph looks the same. So the first one has a height of 25. Now you go to the next one and you write down 45.5 to 49.5, and the next part, the height has the height of 14, and the next one is 7, and so on and so forth. So it looks like this. Along the horizontal axis, you put the boundaries, 41.5 to 45.5. Okay, there is no gap in between. That's one of the differences between histograms and Pareto charts. And 49.5, 53, and you go all the way to the last one, right? The first one has a height of 25. The second one, look at the second group, 45.5 to 49.5, has the height of 14. The third one has a height of 7. The fourth one has a height of 3. And the last one has a height of 1. Okay. You do your best to put it into scale. Now, what I want to mention, when you want to find the width from the histogram, if limits are given, the width is calculated as follows, and we do not add one, upper limit minus lower limit. This is, again, this is what seems to be the case in some texts. I just wanted to mention that. But when we do that, the way I explained it, frequency distribution table, upper limit minus lower limit, plus 1 unit. So you want to be careful with that. We are looking at actually the same question, the same frequency table, okay? The same frequency table. The following frequency table describes the speed of drivers ticketed through a 30 miles per hour speed zone. Prepare the cumulative frequency distribution, prepare the cumulative relative frequency distribution. So I want to quickly go over that. So this is what we had before. And when it comes to cumulative frequency distribution table, it's important to know that that means everything from the start. So what happens, your upper limits, if we go with the limits, the upper limits are not changing, but all the lower limits become the lower limit of the first class. So we're going to write the same thing, but the lower limits will be 42 for all of this. Is one way. The second way, so if you go with the limits, class, you go with the limits. The second way, I hope you remember the boundaries. For the first class, you say everything less than 45.5, the upper boundary of the first class, less than that. Then less than the upper boundary of the second class all the way down. They may use that or this. They're not going to use both, and don't mix and match. So either this one or this one with the following. This is not a cumulative frequency distribution table yet until we go with the next one, which is the frequency. So obviously, the frequency for the first one doesn't change, it's 45. But what about 42 to 49? 42 to 49 would be 25 and 14. So add these two for this one. What about this one? 42 to 53. This one, and this one. So add 7. This one add 3. This one add 1. This last one, if it's done properly, the last one must always be equal to n or summation of x. So this is how we find this is part A together. Either use this one or that. Don't use both. Either with this one or that one. That's why I have the or. But the whole thing becomes a cumulative frequency distribution table. Now, what about the relative frequency? The same as before. Relative frequency is F over R, right? F over R, remember, F over N, my apologies. And remember N is, so the first one again is the same, 25 over 50. But this one starts changing, 39 over 50, 46 over 50, 49 over 50. If we do this right, the last one will always be 1 or 100%. So 25 over 50, 39 over 50, 46 over 50, 49 over 50, 50 over 50. Again, you go with the decimal or percentage or whatever they ask you. If they ask you for the fraction, this would be 1/2, everybody. So you write the proper answer as you are asked. Fractions are always an exact answer. Okay. All right. We are looking at the same question. The following frequency distribution table describes the speed of drivers ticketed through at 30 miles per hour. The same thing. And reminding you of what we have calculated the boundaries, the relative frequencies. And we are asked to draw an ogive of the cumulative percentage distribution. What is an ogive? How do we graph it? When we have a grid along the horizontal axis or the x-axis, we always put the boundaries. So we put 41.5, 45.5, all the way to 61.5. So the very first thing is along the horizontal axis or the x-axis, we put those. What about here? Well, we put either frequency or percent frequency. We just read, we make sure we don't make a mistake. They are asking for the percentage. They are asking for the percentage. So you put the percentage here. You put the percentage along the vertical axis, and we go to 100%. We don't need that, but generally speaking, we may have a percentage larger than 120, but not here. It will never ever happen for us. So never. So what matters is that I want you to see, and I'm going to erase it and do a better job. The lower boundary of the first class always corresponds to 0. The upper limit or the upper boundary of the last class, 61.5, always corresponds to 100% of 1. If it's a frequency, corresponds to n. If it's a percent frequency, corresponds to 100%. If it's just relative frequency, 1. So it corresponds to 1 or 100%. Always. Okay. Now, 45.5, the upper boundary of the first class. This is the upper boundary of the first class. And this is the number you use, 50%. So you put the point there and you connect them with a straight line segment. 49.5 corresponds to 78%. And again, this is not to scale. The next one, 53.5 corresponds to 92%. 57.5, that means the upper boundary of the fourth class corresponds to 98%. Okay, let me actually do a better job on that. And finally, we connect these two. All of them with a line segment. I know it doesn't look that good, but ultimately, this is the graph you have. As you can see, it's similar to that, which is, of course, more exact what you have. Finally, what do we do with the ogive? We want to use the ogive to find the percentage of drivers who drove 47 miles per hour or less. So on the horizontal axis, we locate this number. On the vertical axis, we locate the answer. So it's about 60%, as you can see. And so it reads, number 47 is somewhere between 45.5 and 49.5. On the horizontal axis, which corresponds to approximately 60%, therefore 60%, maybe you read 61% of drivers drove 47 miles per hour or less. That's the meaning of it. Given the following sample represents the ages of 40 tenured faculty at CSULB, n equals 40. Construct a dot plot, construct a stem plot, stem and leaf plot. So first, the definition. Could somebody read this definition for us, please?
A dot plot is a graphical display of data using dots for relatively small data sets where values fall into a number of discrete values or categories. Data values are plotted as dots along a horizontal scale of values. Equal values will be drawn as a stack of dots.
Excellent. So what do we need to do first and foremost? We are going to put this in order. We're going to rank it from the smallest to the largest. And this is the smallest number. This is the largest number. So we put them in order. So first thing first, we're going to sort this from 32 to 63. Now, we are going to come up with a number line. And we put numbers in order. So something like from like 30 maybe to 65 or 70. So we have a number line. But for example, this is 35, this is 40, 45. So we are adding 5. So some sort of a decent scale, okay? And so now we're going to put the dots corresponding to each number. So I have 32 here. I look at the 32 somewhere and I put a dot here. The next number is 37. So this is 35. 37 is somewhere here and I put a dot here. I do the same thing with 39, 40, 42, 43, 45, 47. What happens when I hit 47? So I look at 47 and I put 1 dot for this one, and then I stack it, 1 more. I put 2 dots, and that's what I want you to notice. So I have to put 2 dots. Okay, so for 47, I will have 2 dots. Then I go to 48, 49, 50, 51. I put again 51. I find 51 and I put 2 dots. 52, and then when I get to 53, 1, 2, I put 3 dots. I locate 53 and I put 1, 2, 3 dots, so on and so forth. So I hope everybody is clear as to how we make this one up. And if you look at it, there are more dots at the end. What does it mean? Clearly, the ages range from the smallest value 32 to highest value. Even if we don't have this, but we have just the dot plot, we can see the smallest is this number. We read it 32. The largest one is this number. We read it 63. And clearly the ages range from 32 to 63 years. Also, there is more tenured faculty at older age. Since we have more dots towards the end, there is more tenured faculty at older age. That's the meaning of it. So a plot should give us information, and it does. We are going to continue with the same question, but we want to go with part B. We want to come up with the stem plot, stem and leaf. And again, notice I didn't use the given, but rather the one that we had sorted, we put it in order because that's what we need. We have to use the part that we have sorted. So now, the definition. Could somebody read the definition, please?
Stem plots, stem and leaf plot display the data in order from smallest to largest. A stem plot, like a histogram, is a tool to help you visualize a quantitative data set. The name stem plot is because there is one stem with the largest place value digits to the left and one leaf to the right. We can see the distribution of data while keeping the original data values.
Excellent. So when we look at the numbers, we see that we go from 30s to 60s. So we are going to write 3, 4, 5, 6. The tens digits, 3, 4, 5, 6. Now in front of 3 class, I'm going to put 2, 7, 9. 2, 7, 9, because that's all I have. 2, 7, 9. So if I were to read this, I would read 32, 37, 39. That's how I would read it. In front of 4, I put 0, 2, 3, 5, 6, 7, and 7. I have 2 of them, 8 and 9. So in front of 4, I put them in that order. Again, this gives me 0, 2, 3, 5, 6, 7, and 7. 7 and 7, 8, 9. And you can see, for example, in front of 5, you put 0, 1, 1, 2, 3, 3, 3, 4, 4, 4, 5, 5, 6, 6, 7, 8, 8, 8, 9, 9, 9. In front of 60, you put the rest of them. By the way, it looks like some sort of a, some sort of a symmetry. And again, we have the same result. The ages range from 32 to 63 years. So it shows the smallest value. Even if we don't have this class, here's the smallest value, 32. Here's the largest value, 63. Please understand the meaning of it. Let's say this is missing. Smallest value, 32. Largest value, 63. So largest value in any class, this would be like 39. This would be 49. This would be 59. This would be 63. So the age ranges from 32 to 63 years. And there is more tenured faculty at older age.